Hello everyone, this is Anand Srinivasan. I'm a Lean Six Sigma Master Black Belt and Strategy Champion. And in this video, I would like to take you through 5 simple steps to align and improve your process performance outcomes using Lean Six Sigma methods. So let's take a quick look at the agenda here. We start with looking at how business process shape outcomes. Move on to the 5 steps to process excellence, the DMAIC. Then we walk through these 5 steps with a real-time case study and then look at typical challenges in process excellence as well as ending with some tips and guidelines. So when we say business processes, how do they help to shape the outcomes of our business processes? Any business providing a product or services follows processes or just repeated sequence of steps to provide the right output to their customers. These business process steps and activities may be well documented, just briefly outlined, or they may be a simple step of verbal instructions to achieve the needed output for the customer. Depending on the number of steps, the number of members, different groups involved in the value chain, the quality and timeliness of the output as experienced by the end customer varies anywhere from excellent to poor. So whether it's an existing business process facing customer grievances or a new process aiming for customer satisfaction, reviewing and setting up business process with the right balance is critical. With changes in the customer expectations and market needs on one side, as well as updated technologies, skills, cost challenges on the other, all business processes need to be recalibrated to ensure that they meet the needs of the customer while having the right inputs from the organization side. Moving on to the DMAIC, the DMAIC, 5 steps to process excellence. Define, measure, analyze, improve, and control are the 5 steps outlined by the Lean Six Sigma methodology. And looking at them, the first step, define, talks about prioritize customer needs. Identify critical customer needs, critical customer requirements, CCRs, which are your top 3 to 4 customer success and customer satisfaction metrics of your end customer, and how well are you meeting these end customer metrics? How happy is the end customer with your product or service? Next step is measure, which talks about internal quality measures, where we want to list what are the measurements and quality checks your team is carrying out on your business process to deliver your product services to your end customer. Third step is analyze. The first part of analyze, identify gaps, where we check if your internal measurements and checks to ensure the high quality and value align with the customer critical requirements. If not, identify the gaps. Next part of analyze is the gap analysis, where the gaps which we saw from the above process, as well as the feedback from the customers on poorly rated CCRs on the products and services, we use that to list areas for improvement and as well as the levels of improvement needed to set the right targets for your process measurements so that we get the customer satisfaction. We also need to identify the root causes and why these shortfalls or the poor quality happens. The last step is improve and control, where we implement the improvements. So you get your experts and team to brainstorm solutions as well as the look at similar processes for best practices to arrive at solutions and resolve these problems to achieve the targets and the business in the business process. We start with the simple improvements first, then move on to the harder improvements with the defined timeline. So this is the DMAIC steps of Lean Six Sigma that we are going to use for process excellence. We will look at it with a real-time case study. This particular project was working on imported parts, inward processing time reduction at a factory warehouse. So the background to the project is imported parts coming into a warehouse of a manufacturing facility were getting unduly delayed in the process of receiving and storing in location and sending to the assembly line due to multiple issues of regulatory checks, documentation, inspection of parts, incorrect purchase order information, and so on. The parts were taking anywhere from 5 to 20 working days to get stored after receiving in the yard of the warehouse. So the team moved on to the first one, try and define, prioritize customer needs. The project team identified the internal customer for the workflow as the operations team expecting these parts in the assembly line after they get stored. The key issues identified by the operation teams were undue delay in the time taken to clear the parts after receiving at the warehouse yard to when the parts are available at the assembly line. Whereas the expected time was 2 to 3 days, it was taking 5 to 20 working days as we saw earlier. The team also had no clear visibility where any particular part was in the process of inward receipt and no timeline for when it will be delivered to the client. So this is the first step findings, the critical customer requirements that parts need to be there for in 2 to 3 days after receipt, and real-time visibility of parts in transit and processing. Moving on to the next, step 2 and 3. Step 2 talks about internal quality measures. So the warehouse had targets to clear the received imported parts within 1 to 3 days. However, due to various issues, the parts were stacking up at the yard and taking longer time to reach the line. So this backlog of waiting parts resulting in damages due to weather and multiple handling, and there were even proposals to move them to a new covered space paying extra monthly rent. So what are the gaps? So the team moved on to identify gaps. The project team looked at the reasons for the delays in processing the parts and identified the top three as sequential checking of regulatory correctness of documents after receipt of parts at site and getting updated documents in case of errors and discrepancies. Inconsistencies between purchase order, PO, and the documents received with the parts from the suppliers and getting corrections for those. And there were repeated quantity checks being done on all items, including low value items. With these gaps, so the sequential checking, after parts come to site, discrepancies between PO and invoices, and quantity checks as blanket, these were identified as the top gaps. So the team also mapped the as-is process map with the cycle times. So what you see here, the top part is the parts actual material flow and the where the part moves after receiving through their material processing steps, and the bottom part talks about the paperwork and the done by the supporting departments where it will be where they check for the correctness of the documents and the regulatory compliance part of it is done in the bottom part. So when they mapped the timelines, what they realized was that actual process was taking anywhere up to 12 days. The average was working out to 12 days instead of the intended 1 to 3 days. And the next step, so here, as we said, it's supposed to take 3 days, and we're taking the average is showing up as 12 days. So where was the delay? The initial findings were that most of the delay was happening in these steps in the bottom, mostly with the supply chain management team and the finance team who were doing the document checks, correcting the discrepancies, and doing the regulatory checks. So with this as its process map, team moved on to the next part, which is analyze issues and their root causes. And with that, what they realized is when they ran the data analysis and the root cause analysis, the average cycle time, as we saw earlier, is working out to 12 days with even some processing times extending much further. All regulatory checks were started only after the parts arrived at site, even though information on the parts and the accompanying documents were available when the parts are shipped, or even when the parts are being inspected at customs prior to arriving at site. Due to some prior issues or non-compliance with regulatory norms, the team completing the regulatory checks was extra cautious and overriding the concerns of delays from the operations team to complete their work. Various inconsistencies were also noted in the PO. This is the shipping documents in terms of part numbers, quantity, and other info. So moving to the corrective, implement the improvements and control processes, the team came up with an agreement among all team members during running a Kaizen workshop where all the stakeholders were there. The critical path activities were taken up as a parallel path, such as processing some of the regulatory checks and based on the shipping documents. So if you see here, so somewhere this is the day zero where the parts are expected to arrive at site, and some of these processes can start as early as day -3, that is 3 days prior, with the available documents in soft copies. So the teams start working on it and they get these extra days to process these before the parts actually show up at site. And this right side talks about the material processing steps which happen after the parts arrive at site. So this was one, the parallel pathing. And then the PO instructions were streamlined to ensure all regulatory information were provided by suppliers accurately in their invoices. Some of the quantity checks were rationalized and some eliminated for low value items. The processing time with these measurements with the next set of parts was reduced to 2.5 working days from 12 days. This also helped to optimize the space usage and avoided going in for the extra space as was originally thought of. So this is how the the 5 steps have helped to reduce the processing time and improve the customer satisfaction in this particular case. The team also mapped a process map, the to be process map, which is the improved process flow, where you can see the 4 departments: logistics, material transportation, supply chain management, and finance. These these activities are material flow related, and these are the paperwork related. So if you see here, the activity starts at day -3, when information on the parts arriving on day 0 is already available. So the supply chain teams get started, does their processing, they move it on to the finance team, and when the material does show up at site, the material transportation team start their checks to check for correctness of quantity and condition of the parts and all that. And by the time they're ready to raise the material inward step, they get the clearance from the finance on the correctness of the documents. So they're able to complete it within 2-3 days of receipt at the yard. So this is some of the tools, Lean Six Sigma tools and techniques that were used in the project during the define phase. Prioritizing tools to convert raw customer statements to prioritize CCRs, process mapping to lay out the process, collect the data and review existing data on cycle times, updating process map with the data and identify potential areas, analyze space, basic summary statistics were run, histograms were analyzed, and root cause identification diagrams were used to arrive at the primary root causes. And during the improve and control phase, Kaizen workshop with the stakeholders, brainstorm potential improvements, updated to be process maps, and control measures to monitor the progress. So some of the typical challenges that we see in process excellence. If you see a process, some portions of the process are high quality, but some others are lacking. So we need to look and target those. Modifications over time, outsourcing, technology updates, and automation have led to misalignment with some of the customer needs. Customer segments have increased from one location or demographics to a global audience, and teams across matrix organizations do not have visibility to the entire value chain. These are the challenges. So some best practices is provide visibility to customer satisfaction metrics to all the team and stakeholders, encourage review and continuous improvement ideas from all teams to reduce overprocessing, redundancies, or non-value adds, as well as benchmark with similar businesses or processes to learn where the process can further improve. These are some of the best practices. Some more tips and guidelines to ensure process excellence. Share customer feedback and suggestions to the teams and the new members, especially periodically, because they can be in the dark or some of these. Compile simple steps and easy process steps and communicate visually to all the stakeholders. Look for bottlenecks and overburdened members as opportunities to streamline the process rather than as just issues. Establish priority for quality with first time right, stop to fix, or eliminate root causes. Implement pull techniques to drive demand based on customer needs rather than batch processes. Implement fail proof POCUIC into processes to reduce avoidable errors in the process, as well as utilize data and facts to overcome myths and resistance. Establish financial baseline to highlight the potential gains, once we assign the values to improve processes. Deploy risk management, people change management techniques to address concerns, and encourage the management to monitor the process metrics. So these are some additional tips and guidelines to ensure success in process excellence using the 5 steps method. Thank you for watching the video. Hope it has given you an insight into the 5 DMAIC steps of Lean Six Sigma and how it can be used for your processes or similar processes. So before leaving, I would like to just touch upon other areas where we have used these 5 steps for process excellence with good results. Could be transactional projects like software quality improvement, procurement process, new software implementation, or manufacturing like workload leveling and streamlining, supply chain streamlining. So if you have any such projects looking for process improvement, please do get in touch with us. Thank you.